So, good day to each and everyone. I am Princess Andrea T. Flores and I'm going to report all about the origin occurrence of earthquake. So, first is what is an earthquake? So, it is an intense shaking of Earth's surface. The shaking is caused by movement in Earth's outermost layer. An earthquake usually occurs when rock underground suddenly breaks along a fault. So, last August 31, we experienced small tremor and its epicenter is at the Polomolok, South Cotabato, measured magnitude 4.8. So it is what happens when two blocks of the earth suddenly slip past one another. The location below the earth's surface where the earthquake starts is called the hypocenter, and the location directly above it on the surface of the earth is called the epicenter. And sometimes an earthquake has foreshocks. So next is the focus or hypocenter. The focus is a point on the fault where rupture occurs and the location from which seismic waves are released. The focus is placed inside Earth's crust where an earthquake originates. When energy is released at the focus, seismic waves travel outward from the point in all directions. Next is the epicenter. It is a point on the Earth's surface that is directly above the focus, the point where an earthquake or underground explosion originates. So, it is vertically above the hypocenter or the focus point in the crust where a seismic rupture begins. Do seismicity. It refers to typically minor earthquakes and tremors that are caused by human activity that alters the stresses and strains in the Earth's crust. Most induced seismicity is of a low magnitude. Examples: fossil fuel production, mining, hydraulic fracturing, nuclear testing. So next is the plate edges. Most earthquakes occur along the edge of the oceanic and continental plates. The Earth's crust or the outer layer of the planet is made up of several pieces called plates. The plates under the oceans are called oceanic plates and the rest are continental plates. The plates are moved around by the motion of the deeper part of the Earth, or what you call the mantle, that lies underneath the crust. These plates are always bumping into each other, pulling away from each other or past each other. The plates usually move at about the same speed that your fingernails grow. Earthquakes usually occur where two plates are running into each other or sliding past each other. So there are major causes of earthquakes. First one is the surface causes. Great explosions, landslides, slips on steep coasts, dashing of sea waves, avalanches, railway trains, heavy trucks. Some large engineering projects caused minor tremors. Some of them are man-made and others are natural. Next is the volcanic causes. Volcanic eruptions produces earthquakes. Earthquakes may precede, accompany, and frequently follow the volcanic eruptions, and they are caused by sudden displacements of lava within or beneath the earth crust. Lastly, the tectonic cause. Structural disturbances resulting in the parts of the lithosphere is the main cause of this type of earthquakes. So, faults. What is fault? It is a cracks in the earth where sections of a plate or two plates are moving in different directions. Faults are caused by all that bumping and sliding the plates. They are more common near the edges of the plates. So there are types of faults. First one is normal fault. It's the cracks where one block of rock is sliding downward and away from another block of rock. These faults usually occur in areas where a plate is very slowly splitting apart or where two plates are pulling away from each other. This a normal fault is defined by the hanging wall moving down relative to the footwall, which is moving up. A normal fault, or what you call the footwall, is on the upthrown side of the fault, moving upwards. The hanging wall is on the downthrown side of the fault, moving downwards. So, for example, in the 28th December 1908 Nisana earthquake, it caused more than 80,000 deaths and transformed earthquake science by triggering the study of earthquake environmental effects worldwide, yet its source is still a matter of debate. So these are some of the photos from the Misinas earthquake. So it is truly devastating one. And it caused a lot of damage not only to the people but also to the buildings and infrastructures. So next type of fault is a reverse fault. It is a cracks formed where one plate is pushing into another plate. They also occur where a plate is folding up because it's being compressed by another plate pushing against it. At this faults, one block of rock is sliding underneath another block, or one block is being pushed up over the other. A reverse fault is defined by the hanging wall moving up relative to the footwall, which is moving down. In this time, the footwall is on the downthrown side of the fault, moving downwards, and the hanging wall is on the upthrown side of the fault, moving upwards. When the hanging wall is on the upthrown side, it hangs over the footwall. Next is a strike-slip fault. It is the cracks between two plates that are sliding past each other. You can find these kinds of faults in California. The San Andreas Fault is an example of strike-slip fault. It's the most famous California fault and has caused a lot of powerful earthquakes. Two strike-slip faults, a left lateral strike-slip fault. No matter which side of the fault you are on, the other side is moving to the left. And at the right side, a right lateral strike-slip fault. No matter which side of the fault you are on, the other side is moving to the right. So, the most famous example is California's San Andreas Fault. It stretches some 600 miles or 1,000 kilometers from Southern California to north of San Francisco. The sideways motion of the fault's branches is caused by the Pacific Ocean's crustal plate moving to the northwest under North America's continental crust. So I know that we students and we people are familiar with the movie entitled San Andrea, and it was, and the main actor is The Rock. And as we can see on that movie, it gives a lot of devastation and damage, not only to the lives of the people but also to the buildings. So that's all. Thank you.